Hello everyone, this is a demo video for the complete low voltage unit test that is performed in the CIES lab using the back-to-back converter that is developed over here. For the Simulink program that is going to be used for this experiment, you can watch my previous video on the same topic. For now, I'm just want to give a small overview on the back-to-back converter that is developed in the lab. So, as the theory of the back-to-back converter goes, there are two stages of conversion. First is an AC conversion to a DC voltage, and then from DC voltage, and then there's a conversion to an AC voltage at the output of the back-to-back converter. So in order to do that, we have developed this back-to-back converter over here. So the first stage that you see over here is a conversion from DC to AC of the given signal. So the input to the back-to-back converter is given at phase B, as you can see over here. These electronics parts that you see over here, they are used for the signal conditioning and for the gate drivers of the semicron IGBT that is used over here for this part. This phase, which is phase B over here, is connected through an isolation transformer to the bus bridge node of this microgrid, which is a 3-pole 4-wire bus bridge used that is used to disconnect the main AC line of this microgrid in the lab. So for now, it has been segregated into two phases, phase B and phase A. The phase A is used for the other side of the back-to-back converter, which I'm going to show over here. So using the MATLAB Simulink program, what we're going to do is that we're going to supply an input voltage to phase B using the programmable AC supply source, which is shown over here, and using the number pad given on the source, so we can actually input the input voltage, the frequency, and the current limit which we require. So once that is done and we turn on the supply, it is then connected to the isolation transformer over here, and this isolation transformer then connects to the remaining circuit, which consists of the voltage sensor and the current sensor that you see over here, followed by the filtering. These are the two inductors, and the filter capacitor is shown over here. Alright, so in order to rectify the incoming AC voltage to DC link voltage, we are using a 1200 microfarad capacitor over here, and this is then connected to a voltage sensor so that we can actually measure the DC link voltage that needs to be controlled by the program that has been developed in the Simulink. Now this DC link capacitor is then connected to the other side of the back-to-back converter, which is connected to phase A of the bus bridge that I'm showing over here. So it's actually segregation. So in between phases, there's a back-to-back converter. So again, same concept as was shown for the phase B. Same electronic parts are used. The signal conditioning circuits, followed by the gate drivers and the filtering that you see over here, followed up by filtering inductor and the capacitor. In order to have the output at the bus bridge, this is again connected to the isolation transformer that you see over here, and this is then connected to the bus bridge. So for this experiment, what we're going to do is that we're going to give a 30 volt RMS voltage to phase B, and we're going to set up a DC link voltage across the DC across the capacitor, and we're gonna and what we're doing is that we are setting up an 11 volt RMS voltage at the output of phase A, and then using the bus bridge, we have connected chroma single phase load over here, and what we are doing is that we're gonna set up a constant resistance load and of 200 ohms, and set up an maximum current limit for that. And what we want to see is that whether power can actually flow from the phase B to phase A of the back-to-back converter. And what this chroma single phase load does is that it can actually show you the incoming voltage and the current, and also the power that is delivered to the load. So that's the main idea for this experiment. Using the simulation, the PSCAD simulations, what we came, the numbers that came out was that using 200 ohms as a resistive load with the incoming voltage of 30 volt RMS and an output voltage of 11 volt RMS, we should be getting about 0.5 watts of power across that load. This is a low power test. As we increase on the incoming input voltage and also increase the DC link voltage across the DC link capacitor, we can expect that a higher power can actually be delivered from using this back-to-back converter between the phases. So in order to show the various signals, we have the instrumentations connecting over here. This oscilloscope that you see over here is will give us a current signal that is flowing at the output of between the inductor and the capacitor. This multimeter that you see over here is going to be showing the DC link voltage. This will be showing the output voltage across the capacitor, and this oscilloscope is used to show the PWM signals. So let's run this experiment. Okay guys, the experiment is running right now. We are controlling an output voltage across the capacitor at around 11.5 volts. The current signal you can see right now over here, the DC link voltage is set around 30 volts for the DC link capacitor. And as you can see, for the load that you see over here, the single phase load, we are getting about 0.15 watts of power. We were expected to get about 0.5 watts, but that means that there are some losses in the system. So and that actually proves the fact that we were preparing our third journal paper, which includes some losses in the system which will be there, causing the output power to be lower than expected. So that's the end of the demonstration. That's the end of the experiment, and I'll see you soon.